Hey guys, I'm going to do a short video on how I make the gauges for my locos. I did write an article for Model Engineer that has all the jigs that you need to make these gauges, as well as all the dimensions and drawings. So this video is just to complement the article and maybe give you some of the tricks that I use that's a little bit difficult to put in writing. So basically what I do is I take a standard gauge with a nice range on the face, and the reason why these gauges have such a nice range is because it works in a rack and pinion system where the trade gauges have a lever system on the inside. So you can see it's only got a 90-degree range, where a standard industrial gauge has got a much larger range. I've had a few of these trade gauges from Model Engineering, and I tend to get rid of them pretty quickly because they're not accurate and they fall apart. They're just not as strong as the industrial gauges. So basically this video just deals with stripping this standard gauge, and I won't go through any machining, but the video will go sort of deal with how to put it together and the tricks and stuff like that. To make one of these. But really what you're doing is you're just changing the outside, you're making a nice casing and you're redoing the face, so you have a nice face that fits the model. And if you really want to go one step further, then you can actually make your own pointer, and the pointers are made using an electro stripping process. So again, if you want to get the drawings and the detail on how to make these gauges, then best would be to dig up the Model Engineering article and then have a look at that with this video, and then you should be able to make lacquer gauges for your models. Okay, so we're going to strip this gauge and use a lot of the components in the gauge for our model gauge. So there's two tabs at the back here that you need to find, and if you just stick a screwdriver underneath, doesn't really matter if it breaks because we're only going to use the end of the cover, so that's not a big problem if it breaks. Alright, so we're only going to use the end of the cover, so that's fine, we can still use that. Now the trick is getting this pointer off without bending the mechanism on the inside. Now you can make a tool to do that, or if you just use two screwdrivers it pops off relatively easy. So that pointer we're going to use, or you can make your own pointer depending on what you want to do. Sometimes I make my own pointer, but these pointers are actually quite nice because you can see them. Okay, then the face comes off, and again don't worry about the paint in the face because that's going to be, we're going to put a new nice face on, so that can come off, and those two screws will be used later, so the face can be put to one side. Now the mechanism is important, we're going to use that, but the most important is this Bourdon tube, which is made from beryllium copper. It has very high fatigue resistance, so this is the tube that we want, and we can't bend that off, so we actually want to keep that loop. So what we'll do is we'll undo the mechanism. Now this spring, you just need to move the spring out of the way and make sure that it doesn't catch when you undo the screw. So move it out of the way. There we go. And then that can just be twisted off. So the mechanism we'll use again, and that tube we'll use, we just need to get this tube out of that potting resin, but we'll do that next. Okay, so we're going to take one of the tubes out, and all we need to do is heat it up so that the potting resin starts burning. And you don't want the flame to touch the solder on the tube itself, because that we want to keep. All we're doing is we're just melting the potting resin, and I'll push it from the other side to get the tube out. There we go. So this is the assembly of the mechanism for the pressure gauge, and most of it is done using jigs. So I'm not going to go through the machining of the various components, because if you get to making your own pressure gauges, I'm pretty sure you'll know how to machine your own components. What's more important is the relative position of all the components and the way it fits together. So there's a jig for drilling those two M2 holes that hold the mechanism down relative to the coupling, and that jig was designed based on the original gauge, so that the faces and the holes line up in a horizontal plane and they look good. So that jig was dimensioned in model engineering. So if you want to give this gauge a bash, then that's where you pick up all the dimensions. The next thing you need to do is fit the tube. Now, the original gauge had a venting hole at the back end, and the venting hole showed the guys that do the assembly the start position of the tube. So the backing plate for the original gauge is modified to be a jig, and then the starting point of the tube is marked off using that jig. After doing that, the tube can be fitted, and the back, or this tiny little tube here, that just gets bent and it goes into the coupling, and then a little bit of two-part epoxy gets squirted in that hole using a needle and syringe, and then that seals the tube off quite nicely. And the only other thing you need to do is assemble the mechanism that you stripped out of the original gauge, and that is just the most difficult part, is just catching that the end of the tube and then fitting it like you did disassembling it. So that shouldn't be a problem. Yeah, once you've done this, you can put the face on and put the point on, and you have a really cool model engineering gauge. Okay, so this is calibrating the gauges. With a known and accurate gauge at 80 psi, you can put the needle on at 80 psi. And the reason why I do that is because I normally run my locos at 90 psi. So if you calibrate it at 80 psi, you know that the range where you run your loco, the gauge will be perfect. Then we set it back down to 0. It just needs to go back to down to 0. Okay, that looks good. And then back to 80. That still looks good. Then I normally go 100 and 110. Yeah, that looks good. And then just back to 80. Yeah, so this gauge is perfect at 80 psi up to 100 psi, and it goes back to 0. So this gauge is perfect.